Hello and welcome back. This is a section over volume of pyramids. This is section 7 and this is part of unit 8, modeling with shapes. And what we want to do is we want to talk about expressions to represent volume or unknown measures of right or oblique pyramids. We want to calculate the volume of an unknown measure of a right pyramid, based on a mathematical real-world model, and be able to do the same thing with an oblique pyramid. So, volume of a right pyramid is this. Okay, the volume of a pyramid. Let me change my volume is equal to 1/3 times the area of the base times the height. Okay, so this is very similar to the volume of a prism, okay? It's just that the difference is that we multiply everything by 1/3. Okay, now we could also do this. Okay, we could also say volume is equal to the area of the base times the height, all divided by 3. Okay, either one works. Okay, it doesn't matter which one, just make sure you use either one. Okay, so the base, the first thing I want to talk about is the base of your pyramid. Okay, the base is your bottom face. Okay, your bottom surface. Okay, I'll put bottom face. All right, so I'm going to come over here, and what I know is that if I come in here, right here, okay, this whole area here, all right, what's enclosed into this shape is your base. Okay. So this part here is your base face, all right, is your base. Okay, the edges that make up that base are called your base edge. Okay, and that's that. Okay, so the base edge is that part too. Okay, a lateral face is the triangle, okay, the triangle that makes up the side. So triangle that makes up the sides, okay? And so those are made up over here, okay, with these surfaces. All right, those sides of the triangle. All right. Now, okay, so we've got that. All right, now the apex, now all those points meet at the very, very top here, and we call this the apex. Okay? Now, the other thing that we have is, so we've got the lateral face, we've got the apex. We need the height. Okay, now the height of the triangle is the distance, the perpendicular distance from apex to the base. Okay, and you can see that here as this distance from this apex point here all the way down to this point. This is your height. Okay, the next value that we have is called the slant height. Okay, and the slant height is the height of the lateral face. So the height of lateral face. Okay, and so that's that distance right here. Okay, now one thing to notice, all right, is that there is a right triangle created with the height and the slant height, and I'm going to call the slant height L. Okay, that's usually what we call it, slant height L. Okay, and so it's important that, because sometimes you'll be given the slant height and you'll be given a base measure and you got to figure out the height, and we're going to use this right triangle to do that. Okay, so we've got a couple different types of pyramids. We have the one where we have a square base, okay, and the volume of that would be 1/3 times side squared, okay, because your base is a side length, or has a side length, and then it's a square. So you just, to find the area of the base, you just take side squared. You have a triangular base, okay, and these are all regular bases, okay, so types of pyramids, and I want to disclose these are with regular bases, okay. So you can still use these formulas or the one that I gave you depending on what you have, but these are good formulas to know. So if you have a triangular base, then it's going to be the square root of 3 over 12 times the side length squared times the height. Okay, and still that height is going to be the value from the apex all the way down to the center, and it's going to be perpendicular to that piece. Okay, same thing with a hexagon base. The area of that would be the square root of 3 over 2 times the side length squared times h. Okay, so let's go ahead and let's kind of determine the volume of a pyramid given the slant height. Okay, so now what I know, it says find the volume of a right square pyramid. So when it tells me that I have a right square pyramid, that means that my base is a square. Base equals a square, okay? So what I know about my base length, if I come in here and look at this value here, I know that this length here is congruent to this length, is congruent to that length, congruent to that length, okay? Now I know that my height here, or I'm sorry, my slant height, L, is equal to 5 centimeters, okay? But I don't know what my height is. So the question is, what is this length? Well, this length, because we're dealing with a square pyramid, is going to be half the length of this side, okay? And so what this length from here to here, is 3 centimeters, okay? It's going to be half the length of this here, but we have to write that in. Okay, so now we have to figure out what h is. Okay, now what I know is that I have a right triangle that's created here. Okay, and I know that this length is 5 centimeters. I know that this is 3 centimeters, and this is my height. Okay, so what I'm going to do is this. Okay, to figure out what my height is, I'm going to do h squared plus 3 squared is going to equal 5 squared. If I were a betting man, which I'm not, I only bet on things that I'm certain of, and I am certain of this, that my height's going to be 4. Let's check it out, okay? So if I do h squared plus 9, that's going to equal 25. Subtract 9 from both sides, that's going to give me h squared is equal to 16. Take the square root, h is equal to 4 centimeters, okay? So that's that value there. So h is equal to 4 centimeters. So now what I can do is we can calculate the volume now that I have my height. So the volume, and I'm going to do this, 1/3 times my side length squared times my height. Okay, well my side length is equal to 6 centimeters. Okay, I get that value here. My height is equal to 4 centimeters. Okay, we just found that. All right, so you will have to find some values here in order to evaluate this. Okay, so I'm going to plug those in. So I get volume is equal to 1/3 times 6 squared times 4. All right, so now let's simplify that. And so we've got 1/3 times 6 squared, which is 36, times 4. Now I can take 36 and divide that by 3 here. Okay, and 36 divided by 3 is going to give me 12. Okay, so volume is going to be 12 times 4. And so then our volume is going to be 48 centimeters cubed. All right. So this is a pretty standard question, okay, where you're given the slant height, you're given a side length, you got to figure out what this length is, and you do that because it's half the length of this side, and then you use Pythagorean theorem to figure out what that height is, okay? So let's go to the next page. Okay, on this problem on this page, first one says, determine the space inside a tent. So we have a tent with a regular hexagon base, okay, so that's that. And let's just highlight that we know that, okay? So that's our base is a regular hexagon, okay? And it says, and has a base edge length of 4 feet. So this length right here is 4 feet, okay? And a height of 4 feet, okay? So my height here is also 4 feet, okay? And it says, how many campers can the tent accommodate if the average amount of space a camper needs is at least 20 cubic feet? Okay, so yeah, this is kind of weird. Okay, let's just see what we can do. All right, let's just find the volume first and do that. Now, the formula for the volume for a regular hexagon is the square root of 3 over 2 times s squared times the height. Okay, now our side length that we figured out was 4, okay, right here. And then our height is 4. So if our side length if S is equal to 4 and our height is equal to 4, let's plug those numbers in. So our volume is going to equal the square root of 3 over 2 times our side length, which is 4 squared, times our height, which is 4. Okay? So then our volume, all right, and this is going to be 4 squared, which is 16 times 4 again, which is 64. So I've got the square root of 3 over 2 times 64. I'm going to put that over 1. Now, 64 and 2 divide out. So my volume then is going to be the square root of 3 times 32. Okay, so if I take that and plug that into the calculator, just so we get an actual value out of this, I do 3 square root and then times 32 is going to give me a total volume, okay, of 55.425 feet cubed. Okay. Now they said that if that the average amount, if you're trying to figure out how many campers can this tent accommodate, if each camper needs at least 20 cubic feet. Okay, so I would say that, you take this number, take the volume, so take 55.425 and divide that number by 20, okay, to figure that out. And it's going to give you about 2.7 people, 2.7 campers. Now, that 0.7 of a camper isn't going to be a very happy camper. So, how many could we accommodate? We could accommodate 2 campers. Okay, so 2.7 campers, you can't accommodate 0.7 of a camper because they ain't going to be a happy camper. Okay, then you would accommodate 2 campers. Okay, not really sure if I wrote that right, but we're just making a video. We're just trying to, oh, I did spell it right. Okay, cool. All right, so now we also have volume of oblique pyramids. Okay, so an oblique pyramid is a pyramid where the height of that pyramid, okay, is not it does not go to the center of the base. Does not go to the center of the base. Okay, so the height is still that perpendicular distance from the apex down to the base that's perpendicular. Okay, so it's still going to be perpendicular to this. Okay, so this is your height. All right, same things apply. Okay, when we're talking about finding the volume of these pyramids, the formulas are the same. Okay, but with the height is different. Formulas are the same. Okay, but the height is in a different location. Okay, so let's take a look at a few of these. It says the sides of a regular hexagon measure 5 centimeters for an oblique pyramid. The area of the base is 65 centimeters squared, and the distance from the apex to the center of the hexagon is 10 centimeters. Okay, so what I know, it says determine the volume of the oblique pyramid. This is kind of a tricky question. Okay, these base measures, okay, all these measures here are 5 centimeters. Okay, I know that the distance from the apex to the center, okay, this distance here is 10. All right, so this distance, let me highlight that in red, is 10 centimeters. Okay, now this value over here, this distance that's perpendicular, is your height. Okay, so what we need to do is we need to figure out what this value is here. Okay, we need to figure out what this measurement is. Okay, we'll call that x. And actually, let's not call that x. Let's call that our radius r. Okay, because And I'm calling that the r because that's the radius. So r is equal to the radius of the hexagon. Okay, so we kind of got to reach back a few sections to kind of know what we're doing here, okay? So what I want to do is this. I'm going to draw this regular hexagon real quick. I'm going to do that over here, okay? Because this is going to help me figure out what my my radius is. Well, and let's think about this for a second. If I have a regular hexagon, okay, then here's my center, okay, and I have all these. I'm just going to draw these three triangles here. Okay, what I know is that this is 180 degrees. Okay, if I divide 180 degrees by 3, then I know that each of these angles are going to be 60 degrees. Okay, now if that's a 60-degree angle and these sides are all congruent, okay, then that means these two base angles have to also be congruent. So what I have is I have equilateral triangles. So what I know is that this triangle, if this is 5 centimeters, then this length here, my radius, is also 5 centimeters. So my radius r is equal to 5. Okay? So that's what I've got, all right? So my radius is 5. All right, so I'm going to find my height. So I'm going to do 5 squared plus, let me do this, plus h squared is going to be equal to 10 squared. Okay? Now I also noticed that this shorter length here is 5 and this is 10. This is actually going to be a 30, 60, 90 triangle. But let's just use Pythagorean theorem to solve. So I'm going to get 25 plus h squared is equal to 100. I'm going to subtract 25 from both sides, and that's going to give me that h squared is equal to 75. Okay, I'm going to take the square root of both sides, and I get that h is equal to the square root of 75. Okay? So this is going to actually split up into the square root of 25 times the square root of 3. And so this is going to give me a value of 5 times the square root of 3. So my height, h, is going to equal 5 times the square root of 3. Okay, which is pretty good. All right, so that's my height. Okay, now we know the height of my pyramid now. Okay, the height is equal to 5 times the square root of 3 centimeters. Okay, and the area of the base is 65 centimeters squared. Okay, so I can do a couple different things here. My volume, then, is going to be the square root of 3 over 2 times 5 squared. 5 squared times 5 times the square root of 3. Okay, so this actually works out kind of nice. So if we evaluate this, we're going to get the square root of 3 over 2 times 5 squared is 25, times 5 again is 125, okay, over 1, times the square root of 3 over 1. Now what I'm going to do is I'm going to combine the square root of 3 and the square root of 3. Okay, I'm going to multiply those together. That's going to give me the square root of 9, so my volume is equal to the square root of 9 over 2 times 125 over 1, okay? And so then, after I do that, that's going to give me that my volume is 3 over 2 times 125 over 1. Now, if I do 3 times 125, that's going to give me 375. So my volume is 375 divided by 2. So if I divide that by 2, that's going to give me that my volume is equal to 187.5, and this is centimeters cubed. That's a hard problem. That's really hard. Okay, so you may see something like that, you get stuck, that's okay. I'm here, guys, I'm here to help, all right? So on the next one, it says, in an oblique triangular pyramid, x represents the length of the base edge. So I'm going to come in here, I'm going to label this is congruent, this is going to be x, okay? And the height is twice the length of the base edge. So if I come in here and I draw a height, so a value from my apex down to the center, all right, and draw a right angle, my height is equal to 2x, okay? So if I were to find the volume of the pyramid in terms of x, now remember that my volume of a triangular pyramid is this. Its volume is the square root of 3 over 12 times s squared times my height. Okay, now if s is equal to x, and if I know that h is equal to 2x, then I'm just going to plug those values in, okay? So then my volume is equal to the square root of 3 over 12 times s, which is going to be x squared, times h, which is going to be 2 times x, okay? So now I can kind of combine some things and reorder things and switch them around. So I'm going to do this. I'm going to do volume is equal to the square root of 3 times 2 over 12, and then times x squared times x. Now x squared times x is going to give me x cubed. So I get the volume is the square root of 3 times 2 over 12 times x cubed. Now the next thing I can do is I see that 2 over 12, that simplifies to 1 over 6. Okay, so then, check it out. My volume is equal to the square root of 3 over 6 times x cubed. And that's my volume. Okay, and that depends on x. Okay, so that's all we needed to do, was find the volume of that pyramid in terms of x. So this is kind of a tricky section. You know, it may be hard to visualize what exactly it is that's going on, but, you know, we'll do some things in class and, you know, we'll make sure that you guys understand what's happening. So I hope you enjoyed this video. I had a lot of fun making it. We'll see you soon. Party on, Wayne.